Welcome to video number 9. In this video, we're going to take a look at how we can connect to a remote server and then download a file off of it. Specifically, we're going to download and then play a video file. Now, I already have a remote server set up, linked to the domain name tonyfrizz.com. So first, let's take a look at the video in our browser. For this, I'm going to use Safari. So, open up your browser, and the video file is located at tonyfrizz.com/videos/waterfall.mov. The file is compressed and it's only 30 seconds long, so this way in our application it doesn't take very long to download. Okay, let's get started. So of course, open up Xcode, create a new project. Single view application's fine. I'm going to name my application Video Player. And like always, I'm going to create it on the desktop. So graphically speaking, the application is going to be very simple. We're going to begin with only one button on our view, and tapping on the button will trigger the download and then eventual playing of the movie. So let's open up main.storyboard and get that out of the way first. Like always, in the object library, find button and drag it onto the view. I'm going to title the button Play Movie. Okay, let's set up the IB action for it. Very simply, I'm just going to call it Play. Now let's connect it. Okay, so for the time being, our interface is done. We're going to add something else later on, but for now, this will suffice. So now let's implement the play method. Of course, let's open our implementation file and start off with an empty implementation for our play method. And now it's time to actually download the video file. So first, I'm going to open up the viewcontroller.h file, and at the top, I'm going to add two constants. One for the URL of the video file, and another for the file name that we're going to save it as. So first, let's make a constant for the file name that we're going to assign when the movie is downloaded. I'm going to call it kMovieFileName. And I'm just going to use waterfall.mov, the same that it is on the server. And then next, our constant for the remote URL for the movie, I'm going to call it kMovieFileRemoteLocation. And of course, as we saw before, that's located at http:/videos/waterfall.mov. Perfect. So let's implement our play method. To begin downloading the movie file, we're going to use something called an Nsurlconnection. This is an object that once you create an instance of, begins downloading whatever is at that location, and then reports back to you as the download is occurring using some delegate methods. So this protocol is called the Nsurlconnection delegate protocol. There are only a few methods we're going to use in this protocol, the core ones, and we'll see those in just a couple of minutes. But first, let's actually kick off the downloading of the video file. So first we have to make something called an NSURLRequest object. With an NSURLRequest object, you provide the download link, and you can specify some parameters about how the download is going to be affected. So for example, you can create this request object and assign a custom timeout. By default, I believe the timeout for a standard NSURLRequest object is 60 seconds. I've found that in most cases, the default request object is fine, so I'm going to simply create that object with a reference to our remote URL for where the video is located. So we can do that like this. NSURLRequest, just going to call it request, equals, open bracket, NSURLRequest, and we're going to use a class method called requestWithURL to create an instance of this class. And then we have to create an NSURL object. When passing around URLs from one foundation object to a next, you can't pass in a string. You actually have to create an NSURL object, give that a string, and then pass around that newly created NSURL object. But fortunately, we can do this very simply with an NSURL class method called URLWithString. So again, we call to the NSURL class because this is a class method that will take a string and then return back an instance of itself. And again, that method is URLWithString, and then we could just pop in our remote URL constant. So k movie remote file location. Okay, so now we have a request object. Now we can create an instance of the Nsurlconnection class, give it this request, and it will begin downloading whatever is located at that URL. So once you initialize an Nsurlconnection object, it automatically begins downloading. You don't have to explicitly tell it to start. So once we do initialize our connection object, we don't need a reference to it in this context because there's nothing left to do after initializing it, since again, it'll automatically begin downloading, and because in its delegate methods, it already passes a reference to itself. So we can simply allocate memory for and initialize an Nsurlconnection object. So let's do that now. Nsurlconnection alloc init with request, pass in the request object, and the delegate, of course, is self. So once this line of code is executed, we will have an active connection object, and by means of some delegate methods, it's going to report back to our view controller and allow us to do whatever we need to do with the data coming back from that remote URL. So once this download begins, we're going to receive the video file in many small pieces or packets of information. Because of this, we're going to create a mutable data object, or an instance of the NSMutableData class, and continually append the new packets of data to what has already been downloaded. So for this, we have to, in our .h file, create an instance variable of type NSMutableData, and we're going to call it received data. Alright, so now it's time to implement our delegate methods. So the first is called connection did receive response, and that looks like this. So right before the connection object actually begins downloading whatever is located at the URL we gave it, it's going to make a call to this method first to alert you that the download is about to begin. So here is the perfect place to create an NSMutableData object and store it in our received data instance variable. So let's do that here. Received data equals NSMutableData alloc init. So now we've created a mutable data object with the reference to it stored in our received data instance variable, and now we're ready to store the packets of data that come back during the download in this mutable data object, one piece at a time, or one packet at a time. So let's do that now. The delegate method for this is called connection did receive data, and its header looks like this. So again, as each packet of information is received by the Nsurlconnection object, it's going to call this method to its delegate, of course, which remember is our view controller, and pass in the most recent packet of data it downloaded to this variable here, the data variable. So very simply, we can take this new data variable containing the most recently downloaded packet of data and append it to our received data object so that once the download is finished, we will have all of the data for our video file stored in our received data NSMutableData object. So very simply, that looks like this. Receive data, append data, and we just pass in the new data object. Finally, once the download is finished, the Nsurlconnection object will call the connection did finish loading method. So we can use that to store all the data that was downloaded to a local file in our application's documents directory and then begin playing it. So that method looks like this. So again, this method will be called as soon as the download is finished, and here we can do whatever we want to do with all the data that was downloaded. In the last video, when we needed to archive the application data, we archived it to a file inside of our application's documents directory. We can do the exact same thing here. So next, let's implement that method, the same method we created in the last video, that allowed us to obtain the full path to our application's documents directory. Recall that that method was implemented like this. Now we're ready to use this method and save the video file in the documents directory. So let's go back to our connection did finish loading method. So first, let's obtain our base path or the path to our documents directory. Next, we have to append a slash before appending the file name. Next, we can append our local file name. And finally, we can write our received data to this file. To do this, we're going to use the NSData method write to file atomically. It returns a Boolean value, yes or no, indicating whether or not the write was successful. Let's put the call to this method inside of an if statement and then log to the console if the writing of the data to the specified file was successful. We can do that like this. Now the first argument is obviously the path to which this data should be written. The second argument, atomically, which can be either yes or no, which determines whether the data is written directly to the path you specified, or if it's written to a temporary file and then once the write is complete, changes the temporary file's name to the file path that you specified. If you pass in yes, it goes with the second option where it writes to a temporary file first. This way, if you already had a file at the specified path and you were updating it, if something goes wrong with the writing operation, you still have the original object. This is considered the safer way to do it. Okay, so let's run our application and see if we successfully download and store the movie locally. So let's run the application. So let's click our button. The download shouldn't take very long. And there we have it. So you can see that interacting with the server is extremely simple to do with the iOS SDK. So now it's time to play the movie. To do this, we first have to import another framework. So this far, we've only made use of the Foundation framework and the UIKit framework. To play video files in your app, you have to use the Media Player framework. So first we have to link a reference to that framework in our project. So we can do that like this. Under Build Phases, in the Link Binary with Libraries menu, expand it, press the plus, search for Media Player, and click it and then click Add. Now it's linked to our project, and now we have to import the Media Player header file so we can use all of the classes included in that framework. So open up viewcontroller.h, and beneath the UIKit import, add another import that looks like this. Okay, now we're ready to use the Media Player framework to play our fully downloaded video file. So we'll go back to viewcontroller.m. For this, we're going to use the MP Movie Player View Controller class. This is a special kind of view controller that allows you to play video files in your application. So first we have to make an instance of this class. I'm going to call it MP. And we initialize it using the init with content URL method. And here we have to pass in a URL to where the video file is located. So right now all we have is a file path to where the video file is stored. But the MP Movie Player View Controller class expects a URL to where the video file is located. So we have to convert from a file path stored in an NS string to a URL stored in an NSURL object. Fortunately, there's a class method included with NSURL that allows us to do exactly this. So open bracket NSURL, and then use the file URL with path method, and then pass in the file path, and that's it. So now we can present this Movie Player View Controller using the built-in View Controller method called present Movie Player View Controller animated. So this is a UI View Controller instance method. So we're going to call to self that allows you to present on top of your view controller an MP Movie Player View Controller, thus allowing the user to watch a video file. So again, that method is called present Movie Player View Controller animated. Pass in our Movie Player View Controller object. And then finally, right after presenting this Movie Player View Controller on the screen, we want to automatically begin playing the video file, and we can reference our Movie Player View Controller's Movie Player object via its Movie Player property. In other words, we can play the movie like this. Let's run our application again and see what we've got. Perfect. You can see we have controls for rewinding, fast forwarding, and playing and pausing. You can even scrub through the movie to an exact time. And there's a done button to allow us to close the Movie Player View Controller. Now, how about we add a progress indicator so the user can see exactly how much time is left for the movie to be fully downloaded? Before we do that, however, there's one more Nsurlconnection delegate protocol method we need to implement called connection did fail with error. This method will be called by your connection object if for some reason the downloading of whatever file you specify fails. So for instance, if a user has their device in airplane mode, the download obviously will fail because there's no network using which they can connect to the server that has the file trying to be downloaded. So for this scenario, we're going to display an alert view on the screen to alert the user that the download failed. So underneath our connection did finish loading method, add the following header. This parameter, which is an instance of the NSError class, contains information for exactly why the download failed. But for right now, we don't really care. All we care about is that it did fail, and we need to tell the user that the download was not able to be completed. So let's create an instance of the Uialertview class. Give it a title. A message. Next, let's give our alert view a button to allow the user to dismiss it. And now we can display it. Okay, let's turn our Wi-Fi off for a minute and see what this looks like. Perfect. Keep in mind, for future reference, that if you write an application that connects to a server, but don't alert the user that you couldn't complete the upload or the download, Apple will reject your application from the App Store. So just remember to always provide a pop-up should the connection object fail to connect. Okay, so now let's add that progress bar. Fortunately, there's an object called a UI progress view, indicated by this icon here, and by default, its value ranges from 0 to 1. Before we add our progress bar to the view, let's first instead add a semi-transparent black view on top of the entire view that we already have to make the user aware that they need to wait for this download to finish before they can do anything else with the app. So, in your object library, look for UI view indicator, and that looks like this. Drag one onto your view, then make it the full size of the view it's covering, or our view controller's view. And now in the attributes inspector, change the background color to black and make it semi-transparent. That looks good. Now let's add our progress bar to the bottom of this view. So first we're going to add a label to tell the user that the movie is being downloaded. I'm going to change the font size and now center it. And now we can add our progress view. So first we need a reference to the cover view and the progress view. So let's do that first. Connect them. Now, of course, by default, when the user first launches the application, we want the cover view to be invisible, and also by default, we need our progress view to be at 0. So we can do both of those things programmatically in the viewDidLoad method. We'll set the progress view's progress to be 0, and hide our cover view by setting its alpha property to 0 as well. So now we need a way to track the progress of the download. To start, we need to determine the total size of the video file that we're downloading. Fortunately, we can do that in this method, our connection did receive response method, and this object here, which is an instance of the Nsurl response class, contains a property called expected content length, which stores exactly that, the full size of our video file. So let's add an instance variable to store that so that throughout the download we can keep updating our progress view to match how much has been downloaded versus the full size of the file. The expected content length property is of type long. So let's add a long instance variable, and we'll call it content length. And now we just set that in our did receive response method. And now in our did receive data method, remember this method will be called over and over again as the connection object receives individual packets of information, of data. We can do a float division of the length of our received data object divided by the full expected content length. So that line looks like this. We have to cast a float because the progress property of our progress view expects a float variable. So we have a method here, an NSData method called length, which returns the number of bytes that data object is currently storing. And then we can divide by the expected content length. The next thing we have to do is display the cover view when the download begins and then hide it when the download ends or fails. So in our play method, right before we initialize the Nsurlconnection object that does the downloading, let's set our cover view's alpha to 1. And then in the didFinishLoading method and the didFailWithError method, let's hide our cover view. Okay, let's turn our Wi-Fi back on and run the application and see what we've got. Perfect. The last thing we need to do is when the user taps the Play Movie button, we need to check and see if the video file has already previously been downloaded so we don't have to redundantly download it. We can do this with a class called NSFileManager, and as you can guess by its name, it's a class that specializes in managing files. So it turns out that we don't actually have to create a new instance of the NSFileManager class. We can call to the class method defaultManager, which returns an already initialized FileManager object, and we can use that very simply to check and see if the video file already exists at our local file path. So first we need to obtain the file path for where the movie would be located if it's already been downloaded. Fortunately, we already have that code down here in our connection did finish loading method, so we can just copy this and paste it. Next, let's grab a reference to that already initialized singleton file manager object. We do that using the NSFileManager class method called defaultManager. And now we can check to see if the file exists already using the fileExistsAtPath method. So, if FileManager, file exists at path, pass in our file path. In this case, we want to play the movie, so we can just copy the code down here, again in our connection did finish loading method to begin playing the movie. Otherwise, if it doesn't exist, we begin the download. Okay, let's save and run our application again. So you can see, since we already downloaded the movie the last time we ran the application, no download occurred. Let's reset the iOS simulator and then run the app one more time. So the first time we press play movie, the download begins. But if we press it again, the already downloaded video file is played immediately. So again, hopefully you agree that interacting with servers and downloading files using the iOS SDK really couldn't be any simpler. Anyhow, that concludes this video. Head on over to the next video, video number 10, which is the final video in this series, to see another example of server interaction.